Drywall. How it's made. What if I told you this smooth, quiet wall started with explosions, 600-degree furnaces, and a race against the clock before it hardens? Today, we're going inside the machines that turn raw rock into 34 billion square feet of drywall every single year. And the one step that makes it fire-resistant isn't what you think. Why drywall rules modern construction? Drywall is the quiet hero of modern buildings. It's cheap to install, easy to finish, delightfully smooth on camera, and surprisingly tough. More than 90% of American homes use it for interior walls and ceilings, and its footprint spans homes, hospitals, schools, and sound stages. But how do you transform a chalky mineral into long, perfectly flat sheets that can be cut, screwed, mudded, sanded, and painted within hours? To understand that, we have to start where walls begin. A mountain. Meet the mineral, gypsum. Drywall's core is gypsum calcium sulfate dihydrate. That dihydrate part means each crystal locks in two water molecules. Keep that in mind. Those hidden water molecules are why certain drywall resists fire. When heated, gypsum releases water as steam, absorbing energy and slowing flames. We'll see that trick in action later. Gypsum is abundant, consistent, and easy to process. It dissolves just enough in water to form a smooth slurry, sets quickly, and bonds beautifully to paper. It's the Goldilocks mineral for making walls. Not too soft, not too hard, just perfect for mass production. Step 1. Mining, breaking a mountain into wall material. Open pit mines carve into gypsum deposits that can stretch for kilometers. Crews drill deep, evenly spaced holes, load precisely measured charges, and detonate to fracture thick benches of rock. After the dust clears, excavators swing into rhythm, scooping multi-ton bites of gypsum, loading haul trucks that snake down graded roads to staging piles. From there, the workflow is choreography. Smaller trucks feed stockpiles. Larger haulers shuttle to the plant. Loaders meter the flow into hoppers. Each motion smooths out the natural chaos of the quarry into something a production line can swallow evenly. Step 2. From rock to powder crushing, conveying, calcining. Inside the plant, gypsum takes its first ride down vibrating feeders, through jaw crushers or twin roll crushers that crack boulders into fist-sized chunks, then into secondary mills that reduce everything to granules only a few millimeters across. Conveyors stretch like highways, hundreds of meters delivering rock to the heart of the process, calcination. What is calcination? It's controlled heating in large kettles or rotary kilns that transforms calcium sulfate dihydrate into calcium sulfate hemihydrate, also called stucco or plaster of Paris. Remove part of the crystal's water, and the powder becomes reactive. Later, when you add water back, it recrystallizes, sets, and gains strength. The balancing act: too cool, and it won't set properly. Too hot, and you create dead burned material that never sets right. Uneven heat, and you'll get panels that warp, crack, or set at the wrong time on the line. Operators tune feed rate, gas flow, and residence time, so the powder leaves the kiln with just the right chemistry, free moisture driven off, bound water partially removed, and particle surfaces ready to hydrate on command. And that on-command part matters, because in a few minutes, this powder will meet water and the clock will start ticking. Step 3. Quality control, because you only get one chance. Before the line mixes a single ton, labs pull samples. Technicians test setting time, water demand, strength, density, and impurities. They tweak the recipe, retarders for more working time, accelerators for faster set, starches to improve bond to paper, foaming agents to control density, and fibers or glass for specialty boards. The goal is consistency. Drywall plants don't just make panels, they make predictability at scale. Step 4. Paper, the unsung super material. Look closely at any sheet. The core is gypsum, but paper is the skeleton that lets it live as a panel. Massive rolls unwind top and bottom liners, guided by tension controls and edge sensors. The paper must be strong when wet, dimensionally stable when hot, and smooth enough to paint, yet rough enough to grab the slurry. The long fibers run parallel to the length of the board for strength when you carry sheets or hang them horizontally. Switch the paper and you can change the product. Moisture-resistant facers, mold-resistant facers, even fiberglass mats for high humidity spaces. And yes, recycled content, it's often baked right in. Step 5. The wet end where chemistry meets deadlines. The stucco meets water and time starts. Pumps send a precisely metered slurry to the forming station. Think of it like icing a never-ending cake. A continuous ribbon of gypsum rolls onto the bottom paper. A second paper layer caps the top. Forming table. Rolls compress the sandwich to exact thickness, commonly 9.5 millimeters, 12.5 millimeters, or 15.9 millimeters, 3/8, 1/2, 5/8 inch. Edge formers shape the sides so two boards meet cleanly for taping. Atomizing sprays burst tiny bubbles and help the core wet out the paper evenly. On camera, you'll see a continuous river of drywall sliding along a belt, still soft, but gaining body by the second as crystals regrow lattice by lattice, knitting paper to core. But there's a catch. If it sets too fast, the line jams. Too slow, and the board sags before the dryer. The sweet spot is minutes, no more. Step 6. Cutting, turning an endless sheet into perfect panels. At exactly the right hardness, flying knives drop in sync with the moving ribbon to slice standard lengths 2.4 meters, 3 meters, or custom orders for commercial sites. Sensors track speed, so the cut stays square. Each newborn panel transfers to a curing conveyor, still warm, still gaining strength on its way to the dryers. And those dryers? They're like wind tunnels tuned to the minute. Step 7. Drying strength, flatness, and paper bond. Dryers are multi-zone tunnels, circulating hot air across stacked decks of panels. The goal? Remove free water from the core without scorching the paper or warping the board. Early zones, higher temperatures to drive off surface moisture. Middle zones, controlled airflow to avoid edge curl and blistering. Final zones, gentle finish to stabilize dimensions. Operators monitor exhaust humidity, core temperatures, and board weight to hit a tight target. Get it right, and panels exit flat, light, and strong, with paper bonded like skin to bone. Step 8. Finishing branding, grading, and stacking. Edges get sealed. Logos and standards print along the sides. Cameras scan for surface defects. Rejected sheets are crushed and fed back into the system. Automated stackers build neat pallets, strapped and ready for forklifts to load outbound trucks. From mountain to loading bay, a single sheet's journey can be measured in hours. The hidden variations. Not all drywall is the same. Type X, fire-resistant. Glass fibers and formulation tweaks increase integrity under heat, buying precious time in fires. Moisture-resistant, sometimes green board. Treated paper and additives slow water absorption. Mold-resistant. Facers and cores resist fungal growth where humidity lingers. Cement board divided by glass mat gypsum. Swap paper for fiberglass mats or cementitious cores for showers, exteriors, or high abuse zones. Lightweight board. Foam and optimized crystals reduce density without sacrificing strength, easing fatigue for installers. Same factories, different recipes, tailored to where the board will live. Installation secrets. Why crews love it. Drywall hangs fast. Score, snap, screw. Joints get tape and joint compound, mud, followed by sanding and skim coats. The paper facer loves paint. The core damps sound better than wood paneling. And the total cost stays low because everything from board widths to screw spacing is standardized. Pro tip. If you've ever seen a wall bow or a seam crack, it's usually not the gypsum's fault. It's framing alignment, humidity swings, or rushing the joint compound cure. Drywall rewards patience and precision. Recycling and sustainability closing the loop. Gypsum is one of construction's most recyclable materials. Offcuts and defective boards can be ground, paper screened out, and the gypsum returned to the process. In regions with strong recycling ecosystems, even demolition waste gets reborn as new panels, often multiple times, without major quality loss. Paper facers frequently contain high levels of recycled fiber. Many plants sit near quarries, ports, or power station byproducts, like synthetic gypsum from flue gas desulfurization, to cut transport emissions and steady supply. But there's a twist. Recycling only works if chemistry stays consistent and contamination stays low. That's why sorting at demolition and careful screening at plants are as important as the machines themselves. The fire resistance reveal. Remember those water molecules trapped inside gypsum? When drywall faces flames, the core gives off steam, absorbing heat like a built-in sprinkler, slowing temperature rise. Add glass fibers and tuned formulations, and you get boards that maintain integrity long enough for people to get out and firefighters to get in. It's not magic. It's mineral physics engineered at industrial scale. The scale. Why the world chooses drywall. Billions of square feet every year, rolling out of synchronized factories that manage chemistry by the minute and thickness by the millimeter. Drywall is fast because the process is continuous. It's affordable because every step, mining, calcining, forming, drying, has been refined to squeeze out waste and variability. And it looks good because paper and plaster were made to be together. From the blast that starts its journey to the paint that ends it, drywall is a rare kind of product, industrial, invisible, and indispensable. If you love seeing everyday materials revealed from the inside out, hit subscribe. Tell me in the comments, which building product you want us to tear down next? Glass, insulation, or something completely different? I'm the factory line, and this is how drywall is made one wall at a time.